Hello students, myself Professor MC Murugesh. Welcome to video course Engineering Drawing Section of Solids and Development. Section of solids. Solids are different externally and internally. To know the internal constructional details, it has to be cut and then views has to be drawn. This cutting of the solid is called section of solids. Views drawn after sectioning are called sectional views. I have considered an example cone, and it is cut by a cutting plane or section plane which is parallel to horizontal plane. After this cone has been cut, we will get section of the cone or section of solid. The top part is called as removable part and the bottom part is called as retainable part. You can also see the animation. Next, development of surfaces. A development is the unfold or unrolled plane figure of a 3D object. It is also called a pattern where the plane may show the true size of each area of the object. When the pattern is cut, it can be rolled or folded back into the original object. We'll see how it is. I have considered a cone which is a 3D object, solid object. Then we have to cut at one end and then unfold or unroll it on a plane area to get the development of it. You can see the animation. After understanding section of solids and development of surfaces, I have got some more examples of section of solids. Here I have got bread which has been cut in order to know the cross section of the slice. Like that, another example, a slice of cucumber, cross section, how it is, will come to know. A slice of log, cross section, how it looks, you can get it. So these things will give the idea section of solids. We'll have some more examples. Here I have got right circular cylinder, wherein which it is cut by a cutting plane perpendicular to HP. And then the cross section obtained is rectangle. I have got cone which is cut by a cutting plane inclined to HP, and then the cross section obtained is ellipse. Right square prism, it is being cut by a cutting plane parallel to HP, and you have got same cross section as square. Then development. You can see that a person is creating a box in order to do the package. How it is obtained? Yes, I'll use my cursor. This is the same box which is also a shape of cube. In order to obtain this, as the definition of development tells, unfold or unrolled of a 3D object on a plane. So I will cut at one end and then unfold it and spread it on a plane. So I'll get this one which is called as development of cube. As all of you know that cube has got 6 faces. Here 1, 2, 3, 4, 5, 6. All 6 faces has been spread on the single plane. Now this can be treated as template. Take the template and keep it on a fresh sheet and mark this boundary and then cut that sheet, fold it back, then you will get the box or cube. This is the application of development. Here I have got a board which is also called as plane. This is cylinder and this is the development of cylinder. I will cut one end of the cylinder, then unroll or unfold it and spread it on a plane, and which is called as development of cylinder. Now this marking which we have done on the drawing board, which can be transferred onto a new sheet that is here and then fold it back. Then you get the cylinder. So this is what the development works. Methods of development of surfaces. Parallel line development for prism and cylinder. We are going to adopt parallel line development. So when you unfold the lateral surface of prisms, all the lines are parallel to each other. Hence it is called as parallel line development. For cylinder, the outer circumference is having a curvature and we do the generating lines. All the lines which you can see where I am pointing my cursor are parallel to each other. Hence it is called as parallel line development. Second one, radial line development. For pyramid and cone, we adopt this method. Here I have got a square pyramid. When you do the development for lateral surface of this pyramid, then all the lines will be having a radial line. Hence it is called as radial line development. Same for cone. All the generated lines are radial to each other. Triangulation development for tetrahedron, this type of method is adopted. Approximate development, example is sphere. Since complete circular thing is there, we adopt approximate development method. After knowing different methods of development of surfaces, then frustum and truncated of a solid. I have constructed I have taken a cone. Then if you cut the cone by a plane which is parallel to HP, perpendicular to VP, and this upper part containing the vertex and the bottom part is called as frustum of right circular cone. This is removable retained portion. Here you can see the same frustum part of the right cone is taken and we cut here, unfold or unrolled and spread it on a plane is called the development. If you fold it back, you'll get this frustum of cone like this. Connect here, fold it back, you get the frustum of cone back. This is truncated. You take the same cone, instead of keeping the cutting plane parallel to HP perpendicular to VP, I have made inclined to HP. When it is inclined to HP, then we get the retained portion which is called as truncated part of right circular cone. Like that, I have taken the cone. As you change the angle of the cutting plane, you will get different shapes. Parallel is circle, inclined is ellipse, parabola, hyperbola, like this. But the difference between frustum and truncated. Cutting plane parallel to HP, frustum. Cutting plane inclined to HP, truncated. Development of lateral surface. In the earlier slide, you saw development of surface. But here we are going to see lateral surface. That's why I have underlined it. I have taken the example of square prism. This resembles as if I have gone to a gift shop, purchased a gift and asked the shop owner to wrap with a cover. He will cover it and then give the gift box. So here, this is the gift. Here in this slide, I am showing the square prism. And all this outer layer, what you can see, which is unfolded and spreaded on a plane, is called as lateral surface of square prism. Square prism is wrapped around by using paper. Then the wrapper is opened and spread out on a plane surface. The resulting figure is called development of the lateral surface of the square prism. Yes, I have taken a general example, a fruit. Outside cover is there, inside fruit is there. I took this example in order to make you to understand what is lateral surface, what is solid. Inside fruit is there, which is solid, outside cover is there. That we call it as lateral surface. Here you can see I am removing the skin, which we call it as lateral surface. Inside fruit is there. Yes. Know the difference? Solid inside where I pointed my cursor. Outside, lateral surface of the fruit. If you bring back to the solid of a square prism, inside this is a solid prism, outside lateral surface of square prism. Application of section and development. One of the best example is the air conditioned duct which you might have seen in malls and industries. This constitutes many which has got rectangular prism, square prism, frustum of square pyramid, cylinder, truncated, many are there. All the combination which are assembled together is one of the best example. Next, funnel. Here you have got cylinder, frustum of cone, truncated of cylinder. All three connected to each other. Then, in the rooftop of an industrial building or a multi-storied building, the outlet where you can see is one of the example of section of solids and development. This you might have seen in the floor mills in order to grind the grains, one of the example of development. In the aviation, all the outer structural body is done with the help of development, like this, what you can see in this picture. Now, in order to give more details, I have considered the same floor mill grinding the grains. And this part is important. I bring it back, which contains three parts: square prism, frustum of square pyramid, cylinder. Let us know more details. This one is square prism, frustum of square pyramid, and cylinder. We will see how it is fabricated or how it is done. First, let me take square prism, which we call it as development of square prism. Yes. Then square means it has got four faces. 1, 2, 3, 4. Which are those? You can see in the picture 1, 2, 3, 4. I'll point my cursor. So this is the actual object's square prism, which I will make a cut at one end and unfold and spread it on a plane to get the development of square prism, like this. With the help of this, mark on a fresh sheet all the boundaries, cut it, fold it back, you'll get square prism. Next, we'll see frustum of square pyramid. This is the square pyramid which has got four edges and vertex, four triangles, slanted triangles. Then it is cut. Earlier slide I told frustum means cutting plane is parallel to HP. Now this becomes frustum of square pyramid. I will reverse it. Then this is what we have got here, frustum of square pyramid. Then how to do the development? Yes, there is a simple steps in order to do this, which I will be telling it in later slides, but at this point have the glimpse of it. Then last one, cylinder, pi d is the formula to be adopted and then get the development of the cylinder. We got square prism, frustum of square pyramid and cylinder. Spread it on a plane area. Do cutting, fold it back. We got all the three objects and then it has to be connected one by one in line by adopting the joining technologies. Development of lateral surface of a prism. I have got square prism here, rectangular prism, triangular prism. This is square prism, the drawing, and you have got front view, top view, and the development of it. Lateral surface development of the square prism. This is rectangle prism, length, width, and height. Yes, where you can see the development of it. Then triangular prism, the development of it. You saw all the three types and development of it. We'll solve one by one with the problems. Draw the development of lateral surface of a square prism, base side size 30 mm and axis side 60 mm, resting on HP with one of its sides. After understanding the problem with the given data, we will start how to do the development. There are two steps to solve the problem. First step, orthographic projection. Can you see the length of the XY line? It is very short. I'll tell why it is done. As we are adopting first angle of projection or first quadrant system, VP is above XY, HP is below XY. Front view comes above XY, top view comes below XY. As per the data given in the problem, it is resting on HP with one of its sides. So I have to start my first view below XY like this, making with one of its heads resting. Then I've got side size 30 since it is square, both sides are equal to 30. Then you know the notations or how to name it, which you have to refer for projection of solids. Since it has got top four corners A, B, C, D, bottom four corners A1, B1, C1, D1, which cannot be seen by the observer in the top view, hence they are represented in the brackets. Then do the vertical projectors, then draw diagonal. These lines are thin, which we call it as construction lines, and these are made only to get the center of the top view. From here, draw vertical projector. From there, draw the axis. Axis height is equal to the prism height, which is given as 60 mm. Then draw the front view and do the notations. Again, please do refer projection of solids, how to do the naming. After having front and top view, which is enough to do the development, front view gives height, top view gives length and breadth, so 3 dimensions. Second step, development of lateral surfaces of square prism. Extend this, I am taking the reference same to the line of XY so that I can use the height. Then length is equal to 30 into 4 sides. Let me explain this. One side dimension is 30. How many sides are there? 4 sides. So 30 into 4 times, which is equal to 120 mm. So draw a thin line, which we call it as construction line. Then take the scale, measure equal to 120. What is the height? Height is 60, which is equal to the height of the prism. Yes. And then close it. As I said, side size is 30 mm. 4 times we have to draw. 1, 2, 3, 4. So now I have cut, unfold and spread it on a single plane. Whatever you can see here, which I am making the movement of the cursor, this is development of lateral surface of square prism. You have to name it. Here no restriction like small letter as we do in orthographic projection. This is development. Here you can go for capital letters. The top one is A and bottom one is A1, like that B, B1, C, C1, D, D1. Now, if I fold it back, this line where I can use my cursor and this line, both lines will get joined where I had made the earlier cut. Again I will join here, I'll get back the square prism. That's why here the letter repeats A1 because they get connected to form the square prism. Here A to B is 1. Here also A to B. I have got one rectangle. This I can call it as 1. Like that. B to C 2. C to D. Please have a look in top view. C to D 3. D to A 4. So square prism has got 4 sides. I have unfolded it. This is the development of square prism. Next, Draw the development of lateral surface of a rectangular prism 30 mm into 20 mm and height 60 mm resting on HP with longer side parallel to VP. This is the condition. Again, two steps to solve the problem. First step, orthographic projection, XY line. Since we are following first angle of projection or first quadrant system, vertical plane comes above XY, horizontal plane comes below XY. Yes. In the problem, they had given the condition 30 mm and 20 mm. 30 mm is longer side, 20 mm is shorter side. Longer side is parallel to VP. Here you can see VP, and this is the longer side. We have made parallel to it. And do the namings 30 and 20. Draw vertical projectors. Draw diagonal to get the center. From there, vertical projector axis height is equal to 60 mm. Get the front view and do the notations. Please do refer projections of solid to understand how to do the notation. Then orthographic projection from front view height is obtained, from top view length and breadth, 3 dimension. With the help of this we will do the development. Second step, development of lateral surfaces of the rectangular prism. Take the help of XY, extend the line. Length is equal to side size. Here it is not equal to the square prism. Why? Because the side size is not equal. First take 30, next 20, next I have kept cursor here 30, so here 30, last one 20, 20. So 30, 20, 30, 20. So total is equal to 100 mm. Make this construction line as 100 mm. Height is equal to 60, which is the height of the prism. Then 30, draw a line, 20, draw a vertical line, again 30, draw a vertical line, again 20, vertical line, close it and cover it. So 4 sides of rectangular prism are cut, unfold, spread on a plane to get the development of it. Naming, as I told earlier, there is no restriction to write small letters. Here development we can have capital letters A1, B B1, C C1, D D1 and finally A1, because when you want to replicate this with a new prism, when you fold it, A gets connected, A1 gets connected and you will get rectangular prism. So A to B 1, B to C 2, C to D 3 and back D to A 4. 4 faces of rectangular prism. Next, draw the development of lateral surface of a triangular prism of base side 30 mm and axis side 50 mm resting on HP such that an edge of the base is parallel to VP and nearer to the observer. 2 steps to solve the problem. First step, orthographic projection, XY line, above XY vertical plane, below XY horizontal plane, because we are following first angle of projection or first quadrant system. As per the condition, the prism is resting on HP. I have to start my view below XY. Condition is that one of the edge is parallel to VP and nearer to the observer. So I have introduced the observer. So this is the triangular prism, an edge nearer to the observer, and it is parallel to XY means parallel to VP. So I have satisfied the condition. So 30 mm side size, do the naming, then draw vertical projectors. How to draw to get the center? Let me explain. If you take this as corner, opposite to this corner, you have got an edge. Find the midpoint of this edge and then draw this line. Similarly, go to this corner where I placed my cursor. Opposite to this corner, you have got an edge. Find the midpoint of this, then join from this corner. Intersection of these two lines will get you the midpoint of this triangle. From there, draw vertical projector, then axis side, which is equal to 50 mm, and get the front view. Do the naming, and you might have observed that above axis the hidden line came because to the observer C1 cannot be seen, hence it is made dashed lines, and the notations are also kept in bracket, whereas A1 can be seen, B1 can be seen. So we got front view, height, top view, length and breadth, all the details we got. With the help of this, we'll do the next step, development of lateral surfaces of triangular prism. We'll take the help of XY, draw a line. Here, side size is 30, triangle has got 3 sides, so 30 into 3 is 90 mm. So on the construction line, restrict it to 90 mm and draw the vertical line which is equal to 50 mm. Then 30 3 times because it's a triangular prism. Close it and do the naming A1, B1, C1, and again back A1. Now between A to B is 1, B to C is 2, and back to A, C to A is 3. So 3 surfaces of a triangular prism, and you can see the development of it. Hope you understood square prism, rectangular prism, triangular prism, development of lateral surface. Thank you.